Welcome to another thrilling edition of Drive System. In part 3, we're going to look at two things that you use in code commonly that are very powerful: collections and loops. Collections are a collection of objects. We'll talk about that later. It enables you to carry them around like in a bag and reference them and iterate through them rather than trying to keep track of all of them separately. Loops are repeating code over and over until a certain condition is met. So when that condition is met, then you can exit the loop. There's lots of different loop types. There's for loops, there's while loops, there's for each loops. But we're only going to look at for loops because those are very common and fairly easy to understand. Let's get started. Now, the zero power behavior of a DC motor is what behavior the motor does when it has zero power. That may seem obvious. Like if it has no power, it's not going to do anything. But what it specifically talks about is what behavior that motor should do when, after moving, the set power set to zero. Brake is one of the options, and the other option is float. These are the two enums. We talked about enums last time. This is a way to control data back and forth so that it's very structured. You can either brake or you can float. So I'm a visual thinker. I'm going to show you kind of what those two things do so you can understand why this needs to be set. So if you do the brake, it'll go, and then when you set those up power to zero, the motor itself will lock up and stop, trying to halt the wheel as much as possible. Now, if you have a lot of inertia, your robot may still keep going, but not because the wheel itself is turning. On the other hand, what a float does is when you turn the power to zero, the motor doesn't lock up, and so the wheel will keep spinning due to inertia. So that's a fundamental difference. Brake brakes it. It stops the car. Float allows the car to continue to coast. And braking it could be very useful for autonomous mode, for example, where you want to be at a particular place. Whereas if you're driving around your robot in teleop mode, you probably want float. You don't want it to suddenly stop as soon as you take your power off. So we're going to be setting all four of the motors in the instantiation code, starting with mDrive motor right front. The set zero power behavior is going to be the enum of float for each of them. You want them all basically to be the same, because otherwise you're going to have a robot where half of the sides freeze up, the other half keep coasting. So this is arbitrary. I set it to float. We'll talk about how to change that, allow people to make modification. But I'm basically tapping this in and hitting tab to autocomplete my code. So in a few moments, I've already set up all four motors to float. And this works. This is hard-coded. There are some issues with it, obviously, because it's hard-coded. But as you know, I like to cut things out and put them elsewhere. So I'm going to create a private method called set zero power behavior, if I can spell, and I'm going to pass in an enum, the enum of DC motor dot zero power behavior. I'm going to pass in an enum with the variable name, lowercase, zero power behavior, very straightforward there. And then I'm going to put the squiggly brackets, and I'm simply going to cut those things and paste them in. And what I'm going to do is change the set zero power behavior for each of the motors to the variable name. So what this means is that I can pass in either float or brake, and it will apply to all four of the motors. So up here, I can call that set zero power behavior, and I can pass in the zero power behavior of float, and basically we've done exactly what we had done before. Part of what I want to bring up here, though, is even though I can set it in the instantiation, we want to open up a window or door in our encapsulation code to enable the mode or the command to actually change the zero power behavior for the motors. And that may be because we're going to use a different mode. We're going to do autonomous or teleop. So what I've done is I've changed it to a public method, and I've made the set, the S, lowercase, which is common with getters and setters. Speaking of getters and setters, right now they can set it, but they don't know what its zero power behavior is. So what we're going to do is create a getter. And what the getter is going to return is the enum, the zero power behavior that the motors have been set to. And you notice that is the thing that comes right after public, is what I'm going to return. Now right now I'm not returning anything, so it's not going to be happy with me. But I bring this up now because I want you to understand that one of the common ways to deal sets and gets is to actually use a class level variable. So we're going to go up and create, just like we did with the DC motors, we assigned the DC motors to class level variables. We're going to do the same thing with the enum zero power behavior. We're going to create a class level behavior, m underscore zero power behavior of type DC motor dot zero power behavior enum. And so what happens is when they pass it in, just like we did with the DC motors, we're going to assign that variable, that class level variable, to the zero power behavior enum that got passed in. So pretty straightforward, same thing we've done before. The instantiation code and the DC motors. So we've taken something passed in and assigned a class level. What this means is that we can actually return that class level variable. That's a great way to do setters and getters. So you set it on the set and then you get it on the get. So that means that if they do the get zero power behavior, they'll be getting whatever that class level is set to. And notice that I also set with, even within there, I use the class level variable. That's because I might need to change it. I might need to do something with it before I actually set whatever I'm doing to take place. So down here, I forgot my semicolon. I throw that on there and everything's happy. So I've created a setter and a getter for the zero power behavior. Again, common behavior with setters and getters. Notice they're both, the gets and sets are both lowercase, just standard procedure. The big thing that I want to talk about here are arrays. So I'm going to create an array of DC motor, and that's what the square bracket means. It's going to be an array. And I'm going to call it M underscore all drive motors. And you can imagine what I'm going to do. Basically, I'm going to start adding in all the drive motors that have been passed to me, all the class level variables, into this array. An array is a holder. It'll hold it and it will allow me to do things like iterate through and assign things like the zero power behavior to all of them. So we'll go forward and you'll see how that all works. Collections are central to the concept of programming. A collection is basically a collection of objects or primitive types, like integer is a primitive type. So by sort of grouping them together, you can work with them collectively, you can iterate through them and modify through them. You can see how many you have. And a good example of what could be a collection are the motors, the DC motors that got passed in to the instantiation of our drive system. So we're going to take a look at one particular type of collection, one of the most common ones, called an array. If you can understand an array, you'll understand how collections function. Now, an array is defined, as you see here, with a square bracket. So an array of type pigeon, called myPigeons, is defined by pigeon square bracket myPigeons. That creates a variable named myPigeons, which we know will be an array of pigeons. Now, the array itself doesn't actually exist. It's still a null object. So in order to instantiate it, we would do something like myPigeons equals new pigeon bracket 4. And what this does is create an array which can hold 4 pigeon items. There are no pigeons in it yet, but it can hold the pigeon items, or more specifically, the pointers to the pigeon items, which we'll discuss in a bit. So below is a visual example, a visual image of what the myPigeons object is. It's basically 4 pigeonholes for pigeons. 0, 1, 2, and 3. Arrays are zero-based. Many objects in programming are, and that means that the first pigeonhole is actually slot 0. The second pigeonhole is actually slot 1. And when you're new to programming, this can trip you up a bit. Just remember that arrays are zero-based, and the first item that they reference is going to be 0. This means that this myPigeons array has a property length of 4. So even though the last slot is slot 3, the length of the number of pigeons that this can hold is 4. Notice the length doesn't change depending on the number of pigeons. Let's put a normal pigeon in slot 0, a blue pigeon in slot 1. In slot 2, we're going to put an orange pigeon and a yellow pigeon in slot 3. Now we have 4 pigeons in our array. It is full of pigeons. But we don't have to put them in that order. For example, what if we opted not to put a pigeon in slot 1? We could put a pigeon in 0, 2, and 3, and that would be fine. And note that the length remains 4 because it's not the number of pigeons, it's the number of slots that are available. Now I alluded to the thought that these are not actual pigeons, these are pointers to pigeons, and that's something you have to kind of wrap your brain around. So you could actually put yellow pigeon in both slots 2 and 3, but because it is yellow pigeon, it is actually the same pigeon. So any change you make to any of the pigeons in slot 2 or 3 will be reflected in both of them. So if I put a red mark on pigeon in slot 2, yellow pigeon in slot 2, it will show up on yellow pigeon in slot 3. Because these are the exact same object. What you have here is not an object, but a pointer. So one way to think about it is in your contacts, if you have 2 different entries for a contact with the same number, contact A and contact B both have the same number, and you decide that you're going to call contact A. Well, you get an answer. And then you decide you're going to call contact B. You're going to get the exact same answer because even though they may be 2 different contacts in your contact book, they're both pointing to the same person on the other end. And it's the same with objects in arrays. Both slot 2 and slot 3 are pointing to the same object. Now generally, don't worry, you don't have to worry about this with most collections because the way you interact with them, you will be careful to make sure that they don't double up. But it is a good thing to know that when you talk about objects as opposed to the primitive types, you're actually referencing the same object from within the array if you put it in 2 different slots. So one thing I could do is I could go in and say mAllDriveMotors is equal a new array of size 4, of length 4, which means there's 4 pigeonholes that I can put them in. Now arrays are 0 based, so the first thing I'm going to put in is actually going to be in location 0. That'll be my right front. The second location is actually in location 1, and that's going to be the right rear. And I'll just continue down, assigning them 0, 1, 2, 3, and 4. So I have 4 items, and notice the last item is actually in pigeonhole that's labeled 3. So again, programming commonly uses 0-based structures, 0 being the first number in this case. So I've done that, and that works. You can do it this way. However, there's actually a shorthand, no shock, people like shorthand, ways to do it, so that you don't have to assign it like this. And what you can do to do the exact same thing is you set the mAllDriveMotors to a new DC motor. You don't specify the size when you do this, but you do squirrely brackets, and within the squirrely brackets, you stuff all the objects in order that they should go. So mDrive motor right front, mDrive motor right rear, mDrive motor left front, mDrive motor left rear. And what this, and put a semicolon at the end of it because it's a command. What this has done is it has instantiated an array of DC motor and it has stuffed it with 4 things. So it's the exact same code above as below. It's just easier to read and less chance of doing things wrong. So that's a very common way to create an array. So we've created arrays, very exciting. So what does that mean for us here? Let's talk about for loops for a minute. Looping in programming code is running a particular piece of code over and over and over and over until a certain condition is met, and this can be very effective and very efficient. There's a lot of different loops. There's while loops, there's for each, which is a variant on for loops, but for loops are commonly used with arrays, and so I want to tie the two together. Let's say we have an array called myArray, and in the myArray we have 3 objects, all DC motors, DC motor 1, DC motor 2, DC motor 3. That means that we have 3 things in the myArray. Now I want you to look and notice that myArray 0 is actually DC motor 1. That's because arrays are 0-based objects. So when I'm referring to myArray bracket square bracket 0, I'm actually referring to the first item. Below you'll see a for loop. This for loop is a pretty standard for loop. For paren int I equals 0, semicolon, I is less than myArray.length, I plus plus, close paren, and then the squiggly brackets, which is what we'll loop over and over and over. In this case, it's simply myArray square bracket I, the variable, dot do something, semicolon. So this is a pretty standard for loop, and we're going to look at each of the parts so you can understand how they're constructed. First you have the for. Obviously it's a for loop. This starts the whole process, saying what it is. And within that you have 3 things within the closed paren. The first thing you have is int I equals 0, and if you're familiar with establishing variables, that's clearly a variable named I that's an integer and its default is a 0. So at this point I is going to be equal to 0. Because of scope rules, I will only exist within this for loop, and as soon as we exit this for loop, I is discarded. If you try to reference I outside of this for loop, it will not exist. So I is equal to 0. I want you to keep an eye on that. We've created the variable I, and now we put in the second portion after the semicolon, and that is I is less than myArray.length. This is a Boolean. It's either true or it's false. If it's true, it's going to run within the squiggly lines, and if it's false, it's going to exit the loop. In this case, 0 is less than 3. I is less than myArray.length. And so the third thing it's going to do is actually do the code that is in between the squiggly brackets. MyArray square bracket I dot do something. And because I is equal to 0, we're actually going to change DC motor 1. We're referencing DC motor 1, and we're going to do the method dot do something. So we've actually applied it to the first item. The final step is to go to I++. I++ is something that increments the variable I. I++ simply means I equals I plus 1. But people got tired of writing it the long way, so now they just write I++. What this means is that I is actually now 1. We've incremented I to the number 1. We're going to repeat this loop because we worked and it was successful. We're not going to go back to the initialization because that's taken care of. We're going to skip to the middle section again, and we're going to say is I less than myArray.length. In this case, is 1 less than 3, and the answer is yes. So we're going to skip down to the squiggly lines, myArray square bracket 1 dot do something. So now we're actually affecting DC motor 2. This is how we're going to iterate through the array until we're done. We're just iteration simply going from top to bottom. I++, so now what is I? I is equal to 2. All right, we're going to run it again because we haven't exited the loop yet. Is I less than myArray.length? Is 2 less than 3? Absolutely. So again, we're going to call the code. In this case, it's myArray square bracket 2 dot do something. So now we're affecting DC motor 3. We've done 1, DC motor 2, and we've done DC motor 3. We have iterated through the array, applying the do something method to every one of the objects. Now we increment again, I++, and now I is equal to 3. Now here's where the magic happens. The question comes, because we're running through this again, I is less than myArray.length. Is 3 less than 3? No, it is not. And so we're actually going to exit out of the for loop and be done. So what we've basically done is used a for loop to go through each of the objects that was in the array and apply the same method to each one. This is the power of the system. We can use this to accomplish powerful things, and we'll talk about that as we go forward. All right, so I'm going to create a for loop here for int I equals 0, I is less than M underscore all drive motors. Remember, it's class level, so I can use it here. Dot length. The length is 4 because there's 4 pigeonholes, 4 things. I++, and then for each of those items, again using I to iterate through, I'm going to set the zero power behavior to whatever the class level variable is for set zero power behavior. These two things do exactly the same thing. And you may be wondering, why would I want to do that work? You know, it's not a big deal. Well, it's not a big deal when you have 4 motors. But what if you had 100 or 3 or 27 and you didn't know? What this enables you to do is actually iterate through all the motors regardless of how many there are. If there are 100, this for loop will hit every single one of those 100 motors and set them to the correct thing. So that's really nice and clean. That means I don't have to keep track of things. If there's a new motor, I don't have to go in and set the power behavior. I just add it to the array. And this code will take care of that for me. Again, one of the shortcuts and very powerful things to do, for loops, pretty much all loops are very useful when you start to use them. But this is how you can use a for loop and to iterate through an array.